cubed. Okay, that is why you only take this section. Okay, whereas the example on the top, where is the terminal? The terminals are not in the center, right? So these red dots are all your terminal. So over here, this one is a white flange, right? Analysis. Whereas the one down here is a what? Box beam. May, can you see the difference now?
Yeah, but like it's still related to the thin wall analysis.
Say it again.
I mean,
Yeah.
I mean the launch sphere is still related to the
Thin wall
of the
analysis.
thin wall.
Yes. Yeah.
Oh, okay, all right.
Yeah.
I think
You
they are
have the
individual parts.
the most important thing regarding thin wall or longitudinal is the terminals. If you don't apply the terminal concept, you cannot get it at all. Okay. And by the way,
Yeah, all right.
hold on. You don't get this from the textbook. I use this method to solve a lot of problems. Okay, the textbook will not say this. Okay, but I developed this method and I always use this method for analysis. It never fails. It's always work. Okay, that's why I dare to teach you. Okay,
Okay,
right?
okay, I got it right now.
Good,
Yeah,
good.
yeah, thank you.
Yeah, I want you all to capture this concept. It's more important than anything else. Okay, okay. Now let's go to week 7. Okay.
Sorry, I just have one more question about
Yes.
what May was. So, in the week 7 question 2, the explanation takes a different cue than the one you're taking. So
Yes.
we don't follow that method. We follow yours, right?
Yes, this is so much easier. So
Yeah,
much
yeah.
logical. It does not make sense why they take the vertical part. No reason at all.
Doesn't make sense. Yeah.
Yeah. There you go. You design
Thank
the
you.
terminal. Okay, once you design the terminal, the concept is so easy now. Yes or no? Okay.
Yes. Yeah.
Yeah, I want you all to. That's why when I teach, I always ask you all to apply my technique and the answer, the solution manual. Just look at this value. 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 Okay, but I don't want you all to. I want you all to figure out why they use this. No, you use the technique that I teach you. It's so much easier to understand than anything else. Okay.
Yeah, it's so much easier. Thank you.
Okay. Next, we are going to go week 7. Okay. Now, Lucia, week 7. Wow. Do you mind if I go through this problem again? Is that okay with you? No, Lucia has a mic. Not. Okay, Lucia says sure. I'll be happy. Again, this is your time. Okay. However you want to ask question. Okay, this is your time, and I want you all to be comfortable. Okay. So this is under combined loading. Okay, so there are a few key points that you have to know in this analysis. Okay, so I will try to write down the steps now. Okay, so the first one is uh, draw the transformation. If it's not given, this is given. What do I mean by draw the transformation? So we know that this is x, this is our y, and this is our z. So for this problem is given. Okay, in some problem it's not given, you have to design. Okay, so number 2, so there's number 1. Number 2, locate the neutral axis relative to the element. Okay. So we know H and K are the element. So now you sketch the neutral axis. So this is the neutral axis. Okay. So this is our neutral axis. Okay. And the neutral axis is relative to the what? To the element. Okay. So in this question, element H and K are there. So if the elements are not given, okay, so element, so usually the elements are the location of the assume, okay, assume maximum stresses location. Okay, but for this course, I will always tell you where the elements are. Okay, so that's number 2. So the next thing is determine the axial load or axial forces, shearing force, bending moment, and torque. Okay, and torque. Then follow, so that's the next thing. And then with this, you have to analyze the structure at different planes. So what I mean by that is you have to analyze in the XY plane, YZ plane, and XZ plane. Okay. So you have to check. Okay. So I'm now going to sketch one of the planes, and we'll start our analysis from there. So we are going to start with XY plane. Okay. So first thing you do, you draw your transformation. All right. So this is your X, and then this is your Y. And then you sketch your structure. Okay. So I'm going to sketch our structure now. So 4, 6. Okay. And then we have a 10. Two, 4, 6. Okay. So the first thing you do when you have a cross-sectional view like this, okay, you will firstly draw your neutral axis. So I'm going to draw a neutral axis. Okay. So this is our neutral axis. Then you put in your elements. Okay. Then you locate your element. This is your element K. On top here, this is your element H. Okay. Then you put in the loads. Okay. So you have a load down here, going, hold on, wrong color, I do apologize. You have a load down here, going at 50. Another one down here, going at 150. Then you have a load coming here at 150. And then you have a load coming into you or facing you at 200 pounds. So the first thing that we do now, okay, or not the first thing, is the number 5 point is do not analyze the dots and crosses, okay, just consider the full arrow, okay. So by looking at here, right, we know that we have a px, okay. So px, so we do forces going towards the right, okay. So px is equal to 150 pounds, okay. And it's going to stretch, right? It's going to be induced if you look at element H and K. So px, before we go there, so we know that the formula that we're going to use, okay, is stress X is equal to Px over A, okay. And because it's pulling, so this load basically is transferred to the neutral axis at 150 pounds, okay. So the Px will induce on element H and element K is going to be positive, okay, will be equal to positive. Positive over here means tensile. Negative over here means compression. Okay. And once we have done this, okay, we are going to determine the moment. And it's important to know that this is rotation about Z. Okay. So we're going to determine the moment about Z axis. Okay. So moment, so I'm going to call clockwise. Moment about Z axis. All these are relative to element H and K. Okay. So this will be equal to 150 multiplied by the perpendicular distance is 10. So it's equal to 1,500 pound-inch. And it's positive, the rotation is going this way. So we know, right, it's going down in this direction. Moment about Z. Okay. So if we apply the formula, like stress X is equal to mz over izz multiplied by y, right? We know that element H will be equal to tensile, and element K is equal to 0 because it is at what? At the neutral axis. Okay. So the moment for this, okay, I want to elaborate more. Okay, so if you look at, let's talk about the moment first. Okay, so if we look at the moment, right? So important thing to note, I just call number 6. Okay, when the force vector is parallel to the neutral axis. So for this case, this is the neutral axis. Okay, the perpendicular distance is between the force vector to the neutral axis.